Yo, what's up, honkers? Today, me and Ozu are going to be watching more Styropyro. This time, it's going to be the video where he links 100 car batteries in parallel and blows stuff up and melts things with them. I know, isn't it great? I can't believe he's still alive. Anyways, today's secret word is danger. If you comment the secret word in the comments down below, I will give your comment a heart. Before we get into the video, make sure you go over to Styropyro's video in the link in the description down below for his video and stuff, and go make sure you subscribe and give him lots of love. If this video does well, me and Ozu will react to the 2-hour one that he just released of him doing 400 car batteries instead of 100. Alright, see you in the video!
You ever wake up in the morning and ask yourself, what happens when you wire 100 car batteries in parallel?
Every morning.
I sure don't. No, I do not. I don't ask that question.
I know the feeling.
I do want to know what happens.
If so, you're in luck
Every
because that's
friggin'
exactly
morning.
what I'll be doing today. By wiring all these in parallel, the voltage is going to be the same as a single battery, which is just a bit over 12 volts. Now I realize this seems lame compared to what I usually show on this channel, but you see, this isn't a video about high voltage. Oh no, we're playing with fire today. See that rating
Literally?
right there?
Uh-huh.
That's how much current this battery can deliver for 30 seconds in freezing temps.
Oh.
And that's 850 amps. So, by wiring 100 of these in parallel, we're looking at 85,000 amps.
By the way, I hope y'all know that each one of these batteries costs at least $300 to $500 depending on whenever he got them. That's 100. How much money is this costing to make? Like, let's think about this. This is at least, at the very minimum, $500. Like, no. Yeah, not 500. $5,000. No, wait. $30,000 to $50,000. Right. Yeah, I got it. Thank you, Chatter. I'm fucking I haven't done math in fucking forever.
1,000 amps. Of course, cable and contact resistance is going to limit that somewhat, but I'm curious to see just how ridiculously high the current can get here. I mean, it's one thing to produce thousands of amps for a tiny fraction of a second.
Oh my fucking god.
What
Oh,
does it look
no.
like when you make even more than that over a few seconds?
That scared the fuck out of me. Holy shit.
That is terrifying.
Oh.
He better not slip up and accidentally touch that.
Yeah. By the way,
Yeah.
not wearing gloves. I don't know if you see his hand there.
I see it.
In fact, I'm hoping to achieve the currents seen in a lightning strike with these batteries.
Why the fuck?
The most daunting engineering task for this project was
Why?
coming up with a way to switch these massive currents, particularly one that can break the circuit when tens of thousands of amps
That's
are flown
so
through it.
scary.
I settled on modifying a log splitter, mostly because it can rip apart contacts that
I
weld
see.
themselves together.
Ah,
the
yes.
best part about this switch is that you load it like a crossbow. So let me show you this beautiful mechanism here.
Him being close to these wires just has me so nervous.
Can you imagine if it starts raining?
I didn't even think about that.
Yeah, you want to see lightning? Let it start raining.
Oh man, I'm sure that they're well insulated though. He wouldn't be doing this if it wasn't safe.
So I gotta yank this back while
Are you
feeding
sure?
this pin.
I
It's
don't
not
know.
very easy. Let me just show you.
Oh my god.
Okay, so now it's loaded, and I have to feed this actuator so it can yank out that pin. Let me just show you. You can see the actuator there that yanks out that pin.
Right.
So now, when I hit this yeet switch,
Yeet and
these contacts
frick.
slam together.
You could
And if
hear
I have
it.
some catastrophic failure and need to
That's
kill
so
power,
scary.
I just press this frick button here to rip apart those plates. Oh, and I also have to yank the string at the same time. Seems safe enough, right?
I mean, kinda.
Now, I don't want to bore you with numbers. I feel like it's important to give you a sense of the crazy scale that I'm dealing with here. That bank holds an incredible 320 megajoules of energy. That means that if one of those batteries fails short, the energy equivalent of 500 cars screaming down the highway would get dumped into it all at once.
Oh,
which would probably make a
awesome.
sizable crater.
Yeah?
I really
What
hope that doesn't happen. Now I could go on and
And right after saying that, he just lays on it.
That could make a sizable crater. So many.
With the power of 300 car crashes. I'm going to put my junk on it.
It was 500. 500, Ozu.
500 car crashes. I'm gonna put my junk on it.
On about how clinically insane this is. I should let the rest of the video do the talking here.
Yeah.
I will say that you definitely shouldn't play with car batteries. I mean,
Yeah.
even one can mess you up if you abuse it enough. So yeah, don't try this at home. For the first
Thank
test,
you for the
I'm
service
gonna try a piece
announcement.
of quarter-inch threaded steel rod. This should be easy to melt, but the small size will probably limit the current somewhat.
Okay.
Here we go.
Oh?
It looks like the connection broke there. I mean,
What,
it is only 12 volts. So
Why are
nearly
you
anything can
using a
break the circuit
machete to
here.
touch?
I went ahead and smacked the threads with a hammer a bit to hopefully give more area of contact.
Okay. Hi, Nate. Whoa.
That was instant.
It was slower than I hoped.
Very pretty.
But I did
That's
like the
so
green flames
cool.
from the zinc plating burning off. Here I have a 3/8
That
inch
melted
threaded
so
rod.
quick.
Now this has over double the area of the last rod, so it should pass quite a bit more current.
Probably should. It'll be green, right? Yep, there it went.
There's a little bit of green there for a
Look
second.
at that.
Yeah, don't let Jay anywhere near this. I'm sure he can come up with a few ideas.
Instantly boil a little water.
I think that one was just as fast, if not faster. Let's try zapping some ferrocerium. Now this is the metal alloy that
Have you for the winner?
makes that modern lighter flints, and it makes a bunch of sparks when it's ground down. I'm hoping it makes even more sparks with these batteries. Here we go.
Here we go. Will it explode? Oh, fuck.
Kaboom.
It just
Kaboomy.
exploded. Maybe a bigger rod will give even more sparks. There we go.
I hope you're behind a blast shield of some kind.
Sounds a little muffled.
I'll take that as a yes. Unfortunately, it didn't actually burn all the way through there. Gosh, it's just so hard to keep contact with the voltage being so low. Maybe I just need more weight.
No, what?
This is a
Why?
kilogram
Why?
ingot of bismuth metal. It's super dense and melty, so I'm hoping it will keep enough contact to melt all the way through.
This man is fucking insane. Like, honestly.
Alright, here we go.
It didn't hold on to
Well,
it.
that was messy. It splattered molten metal all over the place, although a lot of it was unmelted. It still made a nice puddle, though.
Wow.
Plus, the oxide layer on the remaining ingot is super colorful.
Ooh, that's
I want to
pretty.
try zapping this half-inch bolt,
Yes.
but this time I'm going to measure the current through it by looking at the voltage drop across the cables.
I wonder if it's safe to be looking at this without any eye protection. Because as I've been watching this, my eyes have started hurting, and I'm wondering about that.
Yeah, I'm sure he's fine.
Here we go.
Oh, good heavens.
Jesus Christ.
Ooh, I don't like that noise.
Yes!
Oh, you don't
It
like
took
the
a while
noise?
for it to secure contact.
Nope,
but
don't
once
like
it
that one.
did, it melted pretty quickly.
Oh, it
The
did get a
oscillogram
little
is
bit
noisy,
green.
but once it made full contact, there was a drop of about 180 millivolts there. Now this is across a mere 16 millionths of an ohm, which means the current there was about 11,000 amps. Not
Jesus
bad.
Christ.
Let's give this saw blade a try. It's nice and flat
Ooh.
and conductive. It should pass a substantial amount of current.
I wonder if it'll have like lightning things coming out the like tips of the blades on the ends. What do you think?
I don't think so.
You don't think
I
so?
think it's just gonna glow.
Think it's just gonna glow and melt.
Yep.
There we go. Ooh.
It certainly burned through quickly. I was hoping it would explode or something.
It didn't
Oh
though.
well. The current there was higher.
Oh
I think at
well.
15,000 amps. Now that's probably near the limit
Oh,
without making some
well.
modifications to the circuit. Now if I can do 15
Said the
kiloamps
mad
for a few seconds,
scientist.
now that would be pretty crazy. And it might be possible with this 3/4 inch
Oh
bulb here.
boy.
Here we go.
Here we go. Holy crap.
You know, for as easy as it is for wires to short when you don't want them to, it's been bafflingly difficult to hold a short across these batteries. Everything just keeps blowing out of place.
Yeah, I wonder why. Probably because it's like forcing stuff through it. I can only imagine the reason.
Tried using all sorts of clamps and different materials, but the results are all the same. Everything breaks contact. So this bank is scary. However, its voltage is not. And that's why I can do this and not feel anything.
How
Besides,
the fuck?
at only 15,000 amps, I haven't even hit the current of the average lightning strike yet. Are you telling me some clouds can do
What?
better than 100 car batteries? So,
Yeah,
is it time to
probably.
throw all these batteries in the ocean?
Apparently.
Nope, not yet. I think using a higher voltage will overcome these problems.
Oh,
so
no.
I rewired the bank for a series parallel arrangement. Now there are chains of 5 batteries
That's
in
a
series. Then all of those are
You
wired
might not
in
want to stay there
parallel.
long, little buddy.
This makes the fully charged
That
bank
moth's
sit at a
gonna
little over
fry
60
up.
volts. Let's start the 60 volt experiments with another 3/8 inch steel rod. Here we go.
All right, here's the high voltage. Bro.
Holy heck, that exploded! The
Holy-
slow-mo
He had to
shows
censor
something
himself.
astonishing here. The rod heated so
Heck.
quickly that its zinc coating boiled off faster than it could burn.
Holy
Oh, that's
And then when
fuck.
the
so
rod finally
cool.
exploded, it left a cloud of greenish plasma as the zinc vapor reacted with the oxygen in the air.
That's
Comparing
awesome.
this to what happened at 12 volts, it's clear there's substantially more current at 60 volts. Sure
Yeah, no
enough,
shit.
I clocked a peak of 30,000 amps, which so happens to be the current of the average lightning strike.
Oh,
I
well,
still
there you
think I
go.
can do better though. Let's see
The
what happens
average
when I
one.
try
What
a
about the
half-inch
best
bolt.
one?
It explodes!
I guess those little clamps weren't enough. I've upgraded to some big boy clamps this time.
Oh, no.
Hopefully
Big
this
boy
does the job.
clamps. I'm sure that'll go great.
It still didn't
I'll
hold
take
it.
that as a no. Yeah, that bolt really does not want to stay in those blocks. In fact, let's take a look here. Yeah, look at that. It just leaves like a big
That's
trace
so
of splattering
cool.
It's just
molten steel
melted.
and copper. Wow.
It looks like a Looney Tunes
Let's
character
see if
like
quad clamping it and
floated
hold it in
against the
place.
wall.
Quad camping? Okay, okay. Nope. Forced itself out
The
anyway.
heavenly lightning refuses to be tamed by pathetic mortal
This was
clamps.
easier at 12 volts. What's going on here?
Well, you know what? It's
Slow-mo
better the
shows
bolt
the
explodes
increased
than the
current has
batteries.
introduced a new problem.
Yeah.
These blocks are getting ripped apart by the gayest force field in physics,
The
the magnetic
gayest
field.
The
force
what?
Now, what's so gay about math?
The gayest force field in physics.
What do you mean?
Oh, I hope he explains it, because
I just want to see a mushroom cloud now that's like, boom.
boom.
Slow-mo shows the increased current has introduced a new problem. These blocks are getting ripped apart by the gayest force field in physics, the magnetic field. Now, what's so gay about
That's
magnets?
a crazy
It turns
thing to
out,
say.
opposites don't always attract like you might think.
Yeah.
Yeah, when you consider magnetic dipoles, north attracts south and vice versa. However, if you look at currents that give rise to those fields, you'll see the reverse happens to them. Opposite
Right.
currents repel, and like currents attract. Now this has a lot of interesting consequences in physics.
And that's why it's the gayest one, Ozzy. Do you understand? Do you get it?
I see.
Yeah.
It's why lightning pinches itself into a fine streamer, and it's also the basis of experimental Z-pinch fusion reactors. In this circuit, it causes the aligned cables to bunch up, while repelling the cables carrying current in the opposite direction, and this is what's ripping apart the copper blocks. In an attempt to fix this issue, I brought in two of the leading experts in crackhead engineering, Alan Pan and the backyard scientist.
Oh boy.
So, you can see I've already tried blowing this thing up before, but like, the current is so gigantic and the magnetic field is so huge that like it doesn't want to stay on the block.
Yeah.
Yeah.
I wanna see what this does.
Yeah, yeah.
looks
it's,
on their faces.
Like, you may not be safe, but like, we'll do it. Yeah, we'll do it.
These are, that's like an inch thick.
Oh
copper.
yeah, it's literally an inch thick. We're gonna take this bad boy.
Oh, so that just. Oh my god.
But the thing is, these huge clamps, they're not enough. It's not. It's that the forces and currents are just so big.
Yeah, I want to put this last.
I can't imagine. They're just like,
There we go.
yeah, this is safe.
Oh.
No,
yeah.
no, it's not.
This is completely insane.
is
deranged. This is
Crackhead
like,
engineering, yeah.
It's
This
so
is-
bad.
Yeah.
just.
All right, everyone ready?
Yeah. Ready.
All right, here we go.
Oh.
Whoa! That bug got out of there.
Poor bug.
You saw the
Poor
bug.
bug.
Yeah.
It's copper vapor.
Really?
It was like, what the fuck just happened?
Fireworks from hell.
Why did everything
Yeah,
explode?
but the contact broke in like, fraction of a second.
Wait, is it safe to look up close?
Sorta.
So the bolt is actually
kinda.
still there.
Yeah.
It just sits on
The
it.
problem here is the,
It just moves it across, like.
yeah, so there's two issues. So it explodes, and but also the magnetic field is all opposing and it yanks it apart. So like
Right.
it barely held on. Like how would you fix this? Like how would you guys
Maybe don't use copper.
find a way
You can't.
to keep
You
to
have to
actually
use
keep
copper.
things on the block and blow up? How would you do it?
I think I could do
It's
it.
the best
How would you do
conductor.
it?
I could do it.
Oh, you just could, yeah.
I just,
Without
Oh,
melting.
you just hold it in place, of course, yeah.
Let me see.
I don't know. Could you Oh, like man. just like drill some holes in the copper blocks and like through bolt it to a piece of wood or something like a 2x6?
I
and
feel
just,
like it would
just
catch on fire,
force
wouldn't
them
it?
in
Maybe.
position.
You might be able to.
I feel like you don't want to keep everything in position. I'm scared. Like if everything
Yeah.
was locked down, I'm scared of what could happen.
Sure, sure.
Like
But like, I want to see that bolt explode.
Like
I want to see
red
it
hot
explode.
and,
Yes.
like, yeah.
And melt. Yeah.
just kind of bolted them to a piece of wood, like on the same piece of wood, right?
That's what I was saying.
Yeah, okay, that's what you were saying.
Oh, so
Yeah.
you have the whole
Yeah, it's
mechanism
like,
and
it's
bolted
like
together.
one piece
The
of
whole
wood.
thing.
Oh, that's a good idea.
Yeah, yeah.
Like I was just expecting like melting and explosive stuff, but not a magnetic force. That's insane. I do like the block of wood idea.
The German word for horror and respect.
Oh,
yeah. whatever that word
Yeah,
is.
yeah.
And there's gotta be
Before
one.
attempting to bolt everything
We
down
want
to
a
block,
bomb.
Yeah, we want a bomb. Nothing about this is a good idea. Of course not. That's why we're
No.
watching it. That way, we don't have to do it ourselves. We can just watch these guys do it.
of wood, we decided to stick a couple cans of 1,2-dimethylethane on the apparatus.
I'm sorry, what?
No, it's gonna
All right.
explode.
You ready for this?
I'm ready. I don't usually wear safety goggles.
You ready?
I'm ready.
All right, here we
So
go.
they're hiding behind a plastic table.
Yes.
Oh my god.
Wow. Oh, it's still alive.
I'm gonna clear it off. All right.
Oh, it's gonna spark. Be careful.
Okay.
Oh my god.
Oh, that's
That was all
terrifying.
the can.
Wow.
Holy
We tried
crap.
sticking a can upright with the hope that it would act like a rocket. It turns out this worked just a little too well.
Oh no.
Whoa.
The rocket went towards them.
Whoa! It is right there.
Is it,
It landed right in front of the
yeah, thank god the current didn't travel further. Huh.
Yeah.
These fireballs were cool and all, but they also had the function of clearing out some of that annoying grass out in front of the batteries. I went ahead and
Annoying
mounted
grass.
everything to
Clearing
a
out the
big block
grass
of
with
wood.
explosives.
Now let's try another
me
half-inch
see.
bolt.
Alright, here we go. It did explode and it stayed in it. Wow.
It just
Now
exploded
it's on the
off of
ground.
there. Wow.
That table would not do shit for them. Yeah, I don't think it would. I think it's
Nope.
just a precautionary, like, this is our safety table. We feel safe behind it.
It'll catch some of the smaller stuff.
Maybe. Depends on how fast it's coming at them, man.
It just exploded off of there. Wow. That's terrifying. Wow, look at the remnants of that bolt there.
Holy
You're
shit.
just- You're welded on there. Wow, it looks like it took about a quarter of a second for that to melt through. And yeah, it peaked at over 40,000 amps. That is insane.
The slow-mo shows two powerful magnetic effects here. There are the cables in back violently pinching themselves into a bundle, and also, there's the broken bolt fragment getting launched outward due to the magnetic forces on it.
Right.
Well, if the half-inch bolt melts now, maybe the 3/4
Even
inch
bigger
will
bolt.
melt
Here we
too.
go.
Big boat.
Oh, it didn't.
Even more explosion. Oh, it stayed.
Interesting.
It melted through. Wow, that is really
Oh.
melted on there.
Oh my
Oh.
Testing
god.
out, like hollowed out the nut.
It literally welded onto it.
Jeez.
That's so cool.
That's cool,
That's
but-
just on there now.
My goodness. Yeah, that liquid
It's
steel
just
really,
on there now.
bonded to the copper there.
Yeah.
Okay, there it goes.
There we
There
go.
she goes.
Jeez.
Wow.
That's
It's
gonna be
funny,
fun, all that
because as I keep trying
leftover
bigger
liquid
loads,
metal.
sparks get launched further and further, even beyond where I'm hiding for these shots. I figured these tests would be intense, but they're already beyond my expectations.
This one's gonna be pretty crazy, I think. There's that bismuth
Oh,
in it
no.
that I couldn't melt earlier. Here we go.
Here we go. Wait, that was it?
I thought its own weight would be enough to hold it down, but clearly not. So I've used these spring clamps to hold it down now.
Okay, okay.
Here we go.
Oh, should I say breathe?
No, no, it is not.
Holy heck.
Holy heck.
I made a huge mushroom cloud. There's not much of this
I
thing
love the censoring he does to himself. Holy heck.
left.
Baby.
It just splattered and vaporized all over the place. Wow.
Wow.
I also managed to spray molten metal on the lenses of 2 of my cameras
Oh.
with that run. Oops.
Oh, that sucks.
At this point in the video, pretty much all the footage is terrifying. But even so, this is probably the scariest shot so far. The batteries managed to take nearly an entire kilogram of metal and turn it into a cloud of vapor and liquid in a second.
It is
Just
awesome,
think
but
of the
also...
lights
Out are
flashing
so hot
from
that
under
they're
the
burning in
cloud.
air, leaving little trails of smoke while raining burning molten metal on everything around it. Afterwards, I found bits of metal splattered on the trees, the sides of my shop, and even the table I was hiding behind. The impressive pyrotechnic display of the bismuth convinced me to try a stick of titanium as well.
Oh, this thing's gonna pop. Yep.
Titanium is used in fireworks for making bright white sparks. And it turns out, it makes these beautiful sparks when being zapped by 100 car batteries as well.
I see.
Who would have guessed?
Who would have
In
guessed?
engineering, there's something called
Wow.
a crowbar circuit, and it's used to prevent an overvoltage from killing the rest of the device. Now it got its name because it shorts the power supply, much like if you were to take a crowbar and throw it across the power rails. Now I think it'd be fun to try the literal interpretation of this circuit. I decided to start with a smaller crowbar here first.
Oh god.
Good. Oh, yes.
That is so cool.
It's green.
Holy heck.
Holy heck.
I had to dodge it.
This is the fourth
This
time
one gave
now.
a really cool
We had to
oscillating effect as
dodge
the
it.
crowbar kept breaking and then regaining contact, which made the resulting explosions especially violent. I threw in the bigger crowbar and this one burned through even faster.
Here we go.
Alright.
Oh,
Holy heck.
Just fire.
Oh wow, the
There's
head
just
of that
fire.
crowbar. Oh my gosh. I just stepped on that and about burned through my shoe.
Oh,
Jeez.
Good job,
Oh
Nummy.
yeah, that's hot.
be fucking
But
careful.
anyway, I was saying how the head of that crowbar there is just welded onto that. It's flattened and melted down. It's insane.
Bro.
I talked
How fast do you think that was this would cook a hot dog? Bro, the fucking hot dog would disintegrate in
Would
5
evaporate.
in literally less than a second. Like it would cease to exist. Yeah.
And I mean that literally. It would literally evaporate. Turn into mist.
It's a fast blacksmith forge.
Yeah.
some magnets in the middle of the wire loop there, and you can see them jump once the current starts. And yeah, I put my camera way too close for this shot. Now something that
tell.
sticks out to me here is when the crowbar finally burns through, and it shoots out a big plasma fireball. My bet is that inductive kickback is playing a role here.
Yeah.
I figure zapping a couple wrenches ought to be fun.
Oh no.
Where's the leak, ma'am? Let's start with a
And
small
where's
one.
the leak, man?
Holy crap. It snapped in half.
This big one should
I'm
be
just
nice
waiting
and
for some of
scary.
the trees to catch on fire.
It lost contact and then regained it again.
Wow. That one got real toasty. Look how
It's still
welded
burning.
that
It's still
thing is
hot.
on there.
Look
Right
at
here,
that.
I have
That's
the biggest
insane.
bolt that I could find at the hardware store. It's an
Of
inch in
what?
diameter and 10 inches long. I think this should be fun to zap with the car batteries.
What's it made of?
This is going
can
to be
take it.
crazy.
Looks
I
like
hope those
copper.
clamps survive.
Brass.
It didn't melt immediately.
Did that melt all the way through?
So it just melted the steel around the threads there.
Oh.
That's crazy. I didn't see that happen with the smaller bolts. So that's what kept it from melting on the way through. It's just floating in the middle. All right, I'm gonna
That is
try
really
it with
weird.
the without the nuts, just the bare
Pretty
bolts
cool.
in there.
Silicon bronze, actually. Gotcha.
Bruh.
It exploded.
Whoa!
Holy heck.
That was so loud. I don't even know what exploded there. It was the fuses that blew. Look at that. They
No.
melted straight through.
Oh.
Wow, that drew over 45,000 amps, and it did it for over a second.
Go.
Well, at least before the fuses exploded. That is bonkers.
Holy
I'm
crap.
actually glad that the fuses exploded here, because it gives a cross-reference for the currents I'm measuring. The Priest fuse current equation predicts that a bank of 10 6-gauge wires in parallel will last a second at 50,000 amps before exploding. And that's pretty much what I just saw. I'm only surprised how loud it was.
Me too.
I upgraded the fuses
honestly.
to 4-gauge, but at this point the batteries are really being abused. So I'm going to do some other experiments before trying the big bolt again. You're probably wondering how well this battery bank works as a plasma cutter.
You know, him wearing the proper, like, personal protective equipment is a little scary. Because for him to want to do that, just, you know.
Well, I am too, honestly. There's only one way to find out.
Oh boy. Rip microwave.
Wow. That works even better than I expected.
Terrifying.
Well, the ground
He
connection
should cut a
melted
car
there,
in half.
So now I just have it sitting on that copper block.
That's a
Let's
lot
give
of
that another go.
damage.
That's fucking nuts.
It's so cool though.
Yeah, I think he got all the way through.
Yeah. I think that'll do it.
Think you got it, buddy.
Let's try that with some steel that's a bit thicker.
You should try it with the tree over there.
Oh, jeez.
What did he say?
Come
that
on.
is?
All right, let's try that again.
That's steel,
I just want to cut
which
it in
is
half.
thicker.
Let's see.
Wow. This is probably what it would actually be like to like have a personal lightsaber. It would not be safe at all to
No,
use.
not in the slightest.
Because that's what it reminds me of. It's like having a lightsaber IRL.
Yeah, it's close enough. Well, actually, on second thought, let's cut it in half the other way.
What I'm worried about is the thing on the
He is
stick
feeding the
coming
baby
loose.
the fun way. Also feed Nugget souls.
Wow. That was wild. Got a few sparks in my head there. Wow, that was fun. I've sprinkled some magnetite there inside that loop of wire. That way you can visualize the magnetic field.
Ooh, that's cool.
Yeah, it really sticks to those cables.
Huh.
So it looks
I've
like an
placed the wire
eye.
loop below a
does.
plastic tray for this shot. It's crazy how quickly the magnetite orients itself near the wire. But then again, the magnetic field here is probably a solid fraction of a Tesla.
Huh.
By attaching some LEDs to a coil of wire and placing it near the cables, I can get some rudimentary transformer action.
Oh my god, it's lighting up.
Oh man, that's scary.
Those LEDs are being wirelessly powered by the alternating magnetic field.
That's
I have
nuts.
this big old SCR here, which is a type of solid-state switch. I want to try popping it with the batteries. Here we go. As expected,
okay.
nothing happens
Nothing-
yet
didn't do
because
anything.
the SCR is off and it holds back the battery voltage. Now let's do a little trolling and apply a signal to the gate.
Oh no.
Yep, there it goes.
It's
Well-
funny because I'm used to silicon dying when looking at it wrong since I'm terrible at electronics. However, the SCR was
Wait a
unaffected
minute. Wait a minute. I'm terrible at electronics. So we're playing with 100 car battery.
Yeah, basically.
Oh my
by
god.
this. The explosion was actually just the cables popping out of the contacts because they're only jammed in there. Let's give that another try.
Wow.
Wait,
Good job.
are you serious? Did it? I don't think that... What?
What? What's wrong?
I think it melted the bolt first.
Oh.
Much to my amazement, the magnetic field shredded the whole setup before there was enough time for the SCR to pop, conducting an astonishing 45,000 amps and snapping one of the mounting bolts in the process. That is one
least it
tough
didn't hit
piece
you.
of silicon.
Yeah.
I mounted everything back in the wooden block to keep it in place. Let's try that again. And
Yeet. Well, it didn't survive that. That's for damn sure.
it turns out the SCR had already failed short from the previous run, which is why it immediately blew up when the battery voltage was applied.
Oh.
This breaker says it can stop a 10 kiloamp fault. We'll see about that.
Yeah. Sure it
All
can,
right,
bud.
let's see how well this circuit breaker holds up.
Wow, it's still on.
Oh, let's see here. So it shows that it had a fault, but it may have actually worked. It may have
Wow.
actually stopped that.
That's
It did.
awesome.
Or did it not? I think it's still alive.
I don't know. Try it
Let's
again.
try it again.
Did it trip?
It's welded to it now,
Oh.
but it still tripped the circuit.
Oh, it
That's
did.
impressive.
Okay. Okay.
I wasn't expecting that. I zapped some magnesium, but the results weren't that impressive, relatively speaking. It melted too easily near the contact points and prevented burn through. So, I decided to try manually keeping contact.
Oh, yeah. That's safe. Boo, 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 boo.
That is crazy! Let's try the same thing with ferrocerium.
Oh.
Yeah, it's like, that one explodes a bit softer than the magnesium did. That's cool. In fact, I bet ya. Where's my science machete?
I think his wires are crossed. I think they are. My science machete.
Oh, that's fun. I think titanium should be even more impressive since it has such a high melting point. Oh, jeez.
Oh, Jeebus.
Wow.
Wow.
And that's how to light the entire yard on fire. I love it.
It
All right,
is,
the
indeed.
titanium flamethrower. Yes, I got it.
Ooh.
Oh, good, I got it. Huh, nice. Before light bulbs were a thing, there was something called a carbon arc lamp that was pretty much just an electric candle. Well, I want to try making one with my batteries. I've connected a couple chonky graphite rods to
Okay.
some cable. I'm going to try initiating an arc by tapping them together.
So the theory is that there should be like a little lightning spark between the two of these that'll like carry over. I
Yeah.
don't think it'll work. Did it work? I think it did.
That is a terrifying sound.
I want to see it on the high
It's
speed camera.
incredibly bright. I smell like nitrogen oxides or something from that. Look how hot that is. I'm gonna apply a really heavy neutral density filter. That way you can hopefully see what that arc looks like.
Bro, we can't see it. Oh, kinda.
Now it's hard to tell, but that arc's actually getting huge. It's like hitting the ground there. That's not just from the splatter from
Oh
the
my
burning
God.
electrodes. The arc is gigantic.
That's scary. No, thank you.
The magnetic
I'm
field
good.
keeps throwing it around.
Oh my God. You can kinda see it. A little bit. It kind of does sound like a wet fart, chat. You're right. Just a little bit.
Radiating back on me. It's ridiculous. I think it's time to revisit the huge bolt that I couldn't melt earlier.
No. Stop.
Alright, I've got a fresh new 1-inch bolt in there. Hopefully this time will be the charm.
Here we go.
Don't do it. Oh. That was it. Okay.
Oh,
Oh, it melted.
it almost hit the camera.
Oh, look at that. It finally burned through. Wow.
Good job.
There's so much heat coming off of that right now. Yeah, I'm pretty sure the radiation coming off of that
Yeah.
bolt lit that wood on fire. Wow.
Yeah, it did.
That thing got hot.
I clocked a peak of just a hair under 50,000 amps there.
No, just a little.
That's quite a bit more than the average lightning strike, and
A little
for a
bit.
much longer duration too. Total circuit power there was on the order of 3 megawatts.
Jesus Christ.
You should not be measuring anything in mega for a YouTube video,
I
Jay.
don't know, I think it's pretty cool.
Who gave you these batteries?
Any desk, yeah. It was their idea. It was their idea.
Oh, no.
It's insane. That's right. This video is sponsored by AnyDesk. In fact, this is
Wait, so he didn't even buy these? Oh my God.
Oh,
No.
I'm reaching out on behalf of AnyDesk because we have a question. What happens when you round up an entire AutoZone supply of car batteries and wire them in parallel? While discussing the topic with the CEO, Philip, your name came to mind as the only person crazy enough to try it. If you're open to the idea, let me know. We'd love to sponsor a video surrounding this burning question.
God bless AnyDesk. Otherwise, we would not have
That's
this.
amazing.
That's awesome.
entire video was their idea, which definitely makes them my coolest sponsor. So, what is AnyDesk? AnyDesk
Yeah, what is
gives
it?
you lightning fast connection to all your devices. For example, I don't even need to be near this terrifying battery bank when I want to blow something up with it. I can walk into an Arby's 1,000
what?
miles from my lab and remotely fire the batteries in a tiny fraction of a second.
Wow.
I love the future.
That's pretty cool.
AnyDesk
Why
isn't
Arby's,
only
though,
useful
bro?
for
Why
sharing 100
Arby's?
car
I
batteries.
don't know.
You can remotely control and manage all your devices with low latency and on low bandwidth. The other guys are notorious for being laggy at the worst possible times, but AnyDesk is always lightning fast. If you're cursed by being the most tech proficient member of your family or friend group, well, AnyDesk can save you time and frustration there too.
Really?
You can remotely support loved ones from wherever you want to be. AnyDesk
I don't want this now. Honestly, I don't want to have access to anyone's computer whenever they're like, oh, can you help me do this? You're good with computers, right? I don't want to have the option to be able to help them. I am tired of being my family's tech support.
is free for personal use and offers business plans that are custom tailored to your
Kibby.
IT and work from home needs. Download AnyDesk now at anydesk.com/styro. So yeah, a big thank you to AnyDesk for sponsoring this video.
Ooh.
Oh, I gotta say, it took a lot longer to make this video than I expected. Now, part of that was I probably spent too much time with the 12-volt experiments.
Yeah, just
But
a little
also
bit.
is I really didn't know what to expect from 100 car batteries. So I mean, with most of my videos, I have a pretty good idea of what the end product is gonna look like. But with these, I
I really didn't know. I mean, I just had to like throw
Right.
things to the wall to see what stuck. And this led to a lot of failed experiments. But at least a few of them were interesting.
I tried microwaving the output of the batteries, hoping it would make a super hot plasma, but the most I could get was a pop. The
Oh.
voltage just isn't high enough for this kind of thing. I also tried
Okay.
saltwater electrolysis, which did work in splitting water
Ooh.
into hydrogen and oxygen, but it just wasn't quite exciting enough. I was hoping for a violent
That is
boiling
cool,
effect,
though.
but I'd need quite a bit more voltage to pull it off in a setup like this. My most disappointing failure was trying to crush a pipe via magnetic pinch.
Yeah, Styro, how many times was the police called on you while you were doing this? Just a question. Because the amount of
just the
pops
FBI.
from your yard and stuff, you have to be on a blacklist from the police at this point, right? If the police don't know this man's address by now. Yeah.
So back in the late 1800s, a lightning rod was mysteriously crushed inward by a lightning strike. And then in 1905, a couple scientists made the connection that it was crushed magnetically by the huge currents that passed through it.
Holy
They
crap.
estimated that a current of 20,000 amps, along with some melting, is what did the pipe in. In order to replicate the effect, I rigged up some pipe with fuses to prevent the pipe from melting all the way through. With each trial, I made the fuse thicker and thicker, which allowed the pipe to heat more and more with each run. I was achieving currents of over 40,000 amps, and the fuses were detonating in these trials. Unfortunately, there was no pipe crushing, even when I let the pipe itself pop from the current. It turns out, it was the alternate explanation that was closer to being correct. A later analysis determined that the rod was actually hit by an unusually powerful superbolt of 150,000 amps, with no
Oh
melting
my
at all.
god.
Since the pressure on the pipe is proportional to the square of the current going through it, that means I'm not even getting
And that's
close
like
to what's
a
needed at 40
third.
kiloamps. Now, if I had a few hundred more car batteries, well then yeah, I could pull it off.
Oh
For
no.
what that would cost, I'd rather build a more accurate lightning machine.
As a whole, the engineering for this project was deceivingly complicated. My channel has a history of circuits that operate much more complex than the schematic would lead you to believe, and this one takes the cake for that. I mean, it's basically the first circuit you had seen in Electronics 101 class.
Right.
And just a battery, switch, and resistor. Now, of course, there's a lot more resistances in reality. The cables
There
have
is.
resistance, the switch has resistance, there's contact resistance, even the batteries themselves have an internal resistance. Now, none of this is easy to measure without just building the whole circuit and putting a huge amount of current through it. In the all-parallel arrangement, I couldn't get past 15,000 amps, and I was really disappointed by this. Where was the resistance coming from?
From inside the batteries,
resistance
I'm
is
assuming.
negligible here, and it's not the cables either.
Maybe.
I'm using the thickest wire in the American wire gauge system, and I'm running 10 of those in parallel. Now, as a side note, there's no measurement that's more American than the American wire gauge.
Oh, cool.
Anyway, the resistance was nearly all in the contact points, and rewiring the bank for 60 volts
Doing
was
the
able to
math for this
overcome
must
most of that.
suck.
In this arrangement, the limiting factor is the battery internal resistance, which means that most of the circuit power is actually going into heating the batteries. I scoped the voltage across a bolt when zapping it, and it dropped to 6 volts. Yikes.
Jesus.
Now the hardest part about this project was actually coming up with a switch. So I mean, you can't just buy a switch like this that can, disconnect these huge currents,
Right.
at least for less than you'd pay for all these batteries. So my original intention was to build a solid state switch using like a huge array of MOSFETs. I realized that would probably have a really high chance of catastrophic failure. So I nerd sniped the members of my Discord server with the hopes that they would come up with a solution.
So you
This was
asked
a
someone
unique
else.
challenge, but I got a lot of creative ideas ranging from MOSFETs to mechanical devices, and even a cursed mercury switch. The Tesla coil master Greg Lay suggested something hydraulic, which gave me the idea to modify a log splitter. I bought a cheap log splitter and some monstrous copper plates, and then brought them to my
And that's
friend
what
Josh
worked.
to weld them up. It was his idea to use the internal spring mechanism to switch it on, which significantly helped keep the switch resistance low when firing. As a side note, this is the same Josh in my early pyro experiment videos that predate my YouTube channel.
Oh, that's sick.
So yeah, thanks to Josh for building the switch. Thanks to all my Discord nerds for the engineering
Are you getting
consults.
rid of all of
And
these?
thanks to AnyDesk for
Don't do
sponsoring
that.
this video and giving me the video idea in the first place.
Finally, I'd like to give an ode
Oh
to the
my
lead-acid
God.
battery. These things are tough as nails. Invented way back in 1859.
Oh my
making them
God.
the oldest rechargeable battery technology. They're also the most recycled consumer product in the US, making them the most sustainable battery technology. To top
Time
it off,
to dump
they're
them in the
preferred
river.
source of charge for electric eels, fulfilling a critical role in aquatic environments. Thanks for watching.
Okay, yeah. So you fished them all out. Okay, good. If you like this video enough, you see that video over on the left there? The 400 car batteries? We're going to do that one if this one does well enough. So if you want to see that, get this video to 2,000 likes. Y'all can do it. I believe. Anyway, I'll see you on the next one. Bye.